Good afternoon. I am going to do an example of a two-proportion z-test and a bit of a two-proportion z-interval. It's for the cockroach worksheet. I've already started some of it, but let me just go over what we're doing. We're trying to find out if there's a difference with this diazinon spray on how many cockroaches it will kill on glass versus plasterboard. So I've already done some of the pre-work. I found the p-hat number 1, the sample proportion for the glass, which was 9 died out of 18 for 50%. I found the sample proportion for the plasterboard, which is my p-hat sub 2, 18 or 13 out of 18, which was about 72%. And I also find the p-hat combined, which was 22 out of 36 cockroaches that died for 61%. We need that p-hat combined because we are going to start under the assumption that both surfaces kill the same amount of cockroaches. The next thing I have to do is define my parameters. Rho sub 1 is the true proportion, population proportion of cockroaches that died after 48 hours on the glass surface after the diazinon spray, and p-hat sub 2 is on the plasterboard surface. My hypothesis is that rho 1 equals rho 2, that there is no difference between the glass and the plasterboard surface. My alternative is that up above it says it suggests that it may persist longer on the plasterboard than on glass because it binds to the paper. Therefore, they expect the mortality rate to be greater on the plasterboard. So the researchers are expecting the plasterboard, which is rho sub 2, to kill more cockroaches than rho sub 1. Our initial paper says nothing about random selection, and I want to comment that they don't have to randomly pick their 18 cockroaches or 36 cockroaches. What they need to have done is randomly select which cockroaches will be placed on the glass and which will be placed on the plasterboard. So keep that in mind when you are writing your first assumption. p-hat sub 1 has to, we have to assume for that one that the cockroaches were randomly assigned to the glass treatment, and for p-hat sub 2 we want to know that there was a random assignment to the plasterboard surface. My next assumption is to see if we have enough sample size to assume that this binomial distribution will actually become is close enough to a normal distribution. So I have 18 cockroaches, and I'm using my p-hat combined. And when I multiply that, I believe it becomes, let's see, 18 times 0.61, 10.98, which is greater than 5. And then I have to do my other n sub 2, which turns out to be exactly the same thing this time. So I could possibly write that I'm going to do both of them just once, but I will be good and try them all. 1 minus 0.61, we have 39%. So 18 times 0.39 turns out to be 7.02. We're very close to the 5, but we are bigger than 5, so that is a good thing. And because those two populations pass the thumb rule here, we can say, so the sampling distribution of mu sub rho 1 minus rho 2 will be approximately normally distributed. All right, my next assumption is to see if I can use my standard error formula. And if I take 18 times 10, that gives me 180, and that is definitely less than the total population of roaches that I could place on glass, or just roaches in general. And we would have to technically do it again, and that is also less than the total number of roaches that we could put on plasterboard. And that being the case, we can say, so the standard error of the sampling distribution is the square root of p hat combined 1 minus p hat combined over n sub 1 plus p hat combined 1 minus p hat combined over n sub 2. We could have also called this SE sub p hat 1 minus p hat 2. Actually, technically, this is SE sub p hat combined. Okay, and that's why I did the p hat combined calculation before I got started to get the 0.61. We have one assumption left. This is very important. We have to assume the two samples are independent. Assume they did this in a room where the cockroaches wouldn't have been able to get on both things. We have that independence assumption. Okay, now we're going to calculate the t-test statistic. Oh, first I have to name my test. I'm going to use a two-sample or a two-proportion z-test for the difference in two population proportions. It might be a little overkill, but that's okay. That's what we're doing for a difference in their population proportions. Okay, to calculate the test statistic, we're in the z world, and we know that this is p hat 1 minus p hat 2. Technically, rho 1 minus rho 2, but in our null hypothesis, we said that this would be 0. And then that is divided by the standard error, which we know is our p hat combined. So looking back up above at the last page, I see that P1 is 50% and P hat sub 2 is 72%. So I'm going to go 50% minus 0.72, technically minus 0, although we don't need to put that in. And then I need to calculate the standard error. And my p hat combined was 61 repeating. So I'm going to have to divide this by 0.61 times I believe it would be 39 over 18 plus 0.61 repeating times 0.39 repeating over 18 also. And actually it's 3/8 repeating, so this should be an 8 up here if I'm going to do the repeaters. If I just round it to 0.61, which I probably should do, let's just do that. I'll erase that and try that again. 0.61 times 0.39 over 18 plus 0.61 times 0.39 over 18. And those 18s aren't always the same number. Many times we can tell we're in the two sample world because our sample sizes do not match up. All right, so calculating this z would give us negative 0.22 over top of, let's do 0.61 times 0.39 divided by 18, and that gives me 0.013216 repeating, and I'm going to multiply that by 2 because that's what would be underneath here. So this is 0.02643 repeating. And then I'm going to take the square root of that with square root of the second answer, and I get 0.16258. So I'm putting 0.16258, and negative 0.22 divided by second answer gives me a z-score of negative 1.353. Okay, if we were to take a look at the picture of this graph, my null hypothesis is that I have a 0. My standard error is approximately 0.1625, so this would be 0.16258, and if I double that 16%, this would be about out to 32%, and if I triple that, it would be somewhere at 0.48, and going the opposite way, we'll just basically put in these numbers that are almost correct but not entirely the right one. Put in my standard scale. When I did this difference, it said it was negative 0.22. Negative 0.22 hits right about here. So my p hat sub 1 minus p hat sub 2 is at negative 0.22%. And that does mirror my z-score, which I calculated to be at negative 1.353. So those two make me feel better that those match up. And now I'm ready for my obtain the p-value. The probability that p hat sub 1 minus p hat sub 2 is less than negative 0.22 is approximately equal to the probability that my z is less than negative 1.353. And then if I look that up on my table, I would look up negative 1.35, and that gives me 0.0885. 0.0885. So they didn't give me a significance level, I don't believe, in the problem, but at any likely significance level, especially if I choose alpha to be my 0.05, which I have recommended that you do if it's not given, I am ready to make my conclusion. And this is my conclusion. This is weak evidence against the null hypothesis. A p-value of 0.0885 means that this observation, or technically one more extreme, would occur approximately 9 out of 100 times by chance. And I'm going to erase my mistake up there. This is not statistically significant at alpha equal 0.05 because 0.0885 is greater than 0.05. Therefore, I better put my capital letters, I do not reject the null hypothesis. And what was my null hypothesis? that the proportion of dead cockroaches on the glass surface. Well, actually, I do not reject the null hypothesis that the difference in the proportion of dead cockroaches on the glass surface and or versus the plasterboard surface is 0. So what this means is the company thought they had a better spray for the plasterboard surface. It would seem that it would tend to stick better to a surface that is porous, but we don't have enough evidence to really say that. I mean, it's, at 0.09, which is not very strong, but we don't have enough evidence to do that. Then the last thing I asked you to do in part B of this question is to explain but don't calculate how we're going to change our checking the assumptions and then complete the I part, the interval part. So I'm going to do that and hope that I don't run out of time here and get too big of a video. Okay, so for a confidence interval, of this situation, I'm thinking that it's probably going to contain 0 because I didn't reject. And I'm doing a 95%, which in the Z world means that this is going to be 1.96 that I'm using for my Z star. First off, the P is going to be the same as before. The A, instead of using the P hat combined, we don't use this because we're assuming that there's a difference and we want to calculate what that difference could be. It's not used. We use P hat sub 1 and P hat sub 2 in the 18 times 0.5, which is 9. And then we'd also do 18 times 0.5, which is 9, and that's greater than 5. And I told you you didn't have to do this, but I thought I'd just plop it in. 18 times 0.72, we know is 13, and that's greater than 5. And so 18 times 0.38 would have to equal 5, and that is just on the borderline. Close. We'd also have to, I guess that's the only place we'd have to do that. Okay, so that's a change in A. For the N, we're going to use a 2 proportion Z interval. And this is the part that I wanted you to show. And the formula for this is Z star times P hat 1, 1 minus P hat 1 over N sub 1, and P hat 2 times 1 minus P hat 2 over N sub 2. So doing that, I already know that the difference in the P hat 1 minus P hat 2 is negative 0.22, and I'm getting that from right here in the T part of phantom, this number right here, which was P hat sub 1 minus P hat sub 2. I already know my Z star is 1.96, but I am going to have to calculate this. So 0.5 times 0.5 divided by 18 plus 0.72 times it should be 28, I believe, over 18. And 2 times 0.28. This up here I said was a 3/8. This is actually a 2, and that would equal 5. Okay, so I have negative 0.22 plus or minus 1.96. And now I'll calculate what that is, and that is going to be, this is 0.1389 repeating. Oops, it's 8 repeating. And I'm going to add that to 0.72 times 0.28 divided by 18. And then I get, for the whole thing, 0.02508. And now when I square root all that, I get 0.15839. Take that times 1.96. I'm getting plus or minus 31%, 3104. And so if I take 0.31 plus negative 0.22, I get 0.09. And if I take negative 0.22 minus 0.31, I get negative 0.53. So this definitely contains 0 in here. So we can't say that there is a difference. My conclusion would be I am 95% confident that the true difference in the proportion between the cockroaches that die on the glass surface versus the cockroaches that die on the plasterboard surface is captured anywhere from 53% dead on the glass surface to 9% higher kill rate on the plasterboard. I'm sorry, that's backwards. 53% on the plasterboard kill rate to 9% more dead on the glass surface. So there really is no difference. The last thing I would like to do is bring up my calculator and calculate these two to double check my answers. So let's do the two proportion z-test first. And I'm going to put these cockroaches in, which I think was 9 and 18. And then we also had 13 and 18. And I just wanted to calculate the difference first. No, I wanted to say that the P1 should be less than the P2. So if I calculate that, there is the 0.08 that looks very similar to this answer here. So I'm going to put my screenshot over here. So it is verified. And then I will put the screenshot in for the confidence interval. And the really nice thing about the calculator on this is that when I go to my stat test 2 proportion z interval, which is right here, it's already in for me. I am doing it at the 95% level, and so there's my negative 53 to my 8. And that is extremely close to what I had. This is negative, or this is 8.7, which does round to 0.09%. All right. Good luck with that. We'll see you tomorrow. Come in early if you have any questions.